So continuing on here with our NAT example, again, what I have configured is that the ASA is doing an inside to outside translation for anything that comes in on this interface is being translated to the pool 200.0.100.0/24. Now we saw with that dynamic translation that the traffic is allowed to move from the inside out, but it cannot move from the outside in unless the translation has already been initiated from the inside. And that's the main difference between the static and the dynamic translation. That the static translation can be having the traffic originated from the outside and then go in. Now, there was a problem in the syntax that I had on the ASA where I was saying NAT inside, rule number 1 says that any traffic, regardless of what the source is going to go to the NAT rule. This means that when traffic is moving from the inside to the DMZ, that it would also have to be translated. That either I would have to define a global pool that it's being translated to, or run what's known as a NAT exemption to remove it from the NAT process. Now, we'll come back to this problem in a minute when we talk about the identity NAT and the NAT exemptions. But first, let's look at the static port forwarding from the outside to the inside. So what I want to do is have hosts on the outside, hit the address that is 200.0.122.100, and I want this to forward inside to the Windows server, but specifically just at TCP port 80, because that's what they're running the web server process on. So on the ASA, I need to create a static mapping that is going to be from the DMZ interface to the outside. So we'll say static. The traffic is coming from the DMZ. It's going to the outside. And we're going to do this based on a port translation. So a specific TCP port. The global address that we are translating to is 200.0.122.100 using port number 80. When traffic is going to the real DMZ host, 10.0.0.100 at that same port 80. So in this case, we're doing essentially both the NAT statement and the global statement at the same time, where the source address that's being used, which is here, the 10.0.0.100 at port 80, is now going to be listened for on the outside interface as 200.0.122.100 at port 80. So now what this means as an outside to DMZ flow, I would need to allow the traffic that is coming in towards this address as an access list exception. So if we were to go to the outside, let's go to router 2. And from router 2, I'm going to telnet to 200.0.122.100 at port 80. On the ASA, if we turn logging on, and we'll log to the console at level 7, what we should see is that when this traffic is sent into the ASA, it says it's being denied. It's being denied by the access list we have applied outside in, which is normally what we would expect because we're moving from the low security interface to high. We're trying to move from 0 to 50. So I need to apply an exception inbound to this. But the key here is that it says the traffic that is getting dropped is the traffic going to the 200.0.122.100 address. So when the ACL is classifying the traffic back in, we need to use the post-NAT address, not the pre-NAT address. So now when I say show run access list, for access list outside in, I need to say permit TCP any host 200.0.122.100 equal to port 80. So this would be that individual flow. Now when router 2 tries to connect to that port, it should be forwarded towards them. Now you'll see there are some examples in the the volume 1 workbook of how to do this. If you knew the actual syntax for the HTTP GET, you can't actually download the pages. So it'd be the same as using like just a raw TCP session to the server. But at least we can tell based on this, the connection is occurring and the translation is happening. On the ASA, if we look at the show xlate, and specifically the show xlate detail, we'll see that this translation is a static TCP port address translation. So it says R for port map. That if traffic goes on the outside to 200.122.100 at port 80, it's actually being redirected to the DMZ at 10.0.0.100 at port 80. Now, from the inside network, though, when we look at router 5 or router 6 now trying to reach the server on the DMZ, there's a problem with the NAT classifier as the traffic comes in this interface. And it has to do with the fact that when I created the NAT rule, I was not specific as to what exact traffic I want to be matched by the classifier. I said, essentially, if we show over on NAT, I said anything on the inside interface. So regardless of whether it's going to the outside, regardless of whether it's going to the DMZ, there should now be a corresponding global statement that is matching this NAT rule for all of the outbound links. Now, from router 5's perspective, if we were to do the same thing, let's telnet to the server, we can see the connection is refused, but the reason why is that there's a failure in the translation, which is going to lead us to the next type of NAT, which is the identity NAT and the NAT exemptions. And these two are used specifically for this type of scenario, where identity NAT is used to translate an address to itself, where essentially it's the same on the inside and the outside. Now, typically you would only need identity NAT when NAT control is on, because otherwise there's no reason to do a translation. So if I wanted the hosts on the inside network here, which is the 10.0.125.0, if I want them to send their traffic out and it not be translated, the only thing I need to do is just not configure a translation, because NAT control is off in this version by default. But the problem is now I did configure a NAT rule, so now it's intercepting all of the traffic that's going in that interface. So I could fix this with an identity NAT, but it's actually more appropriate to fix this with what's known as a NAT exemption. Now, a NAT exemption is similar to the identity NAT, but it allows the traffic from the outside to be initiated to the inside. So an identity NAT would be considered a dynamic translation, where a NAT exemption would be considered a static translation. Now, the reason that we would typically do this is to remove or exempt a particular traffic flow from the NAT process. And that's exactly what I need to do in this case. I need to say that when traffic is moving from the inside interface to the DMZ, it should be exempt from the NAT process. I don't want it to hit the classifier. Now, typically you would normally use this with your IPsec configurations, where let's say that I had a tunnel that was from ASA 2 to router 3. And this is an IPsec LAN-to-LAN tunnel. And I am trying to encrypt traffic between the 172.16.34.0 network and the 10.0.125.0/24 network. So here I have the traffic routing over the tunnel. But additionally, on the inside interface, I created a NAT process that says when I'm going to the outside, I want to be translated to 200.0.100.0/24. Because for public internet access, I'm going to need to have the public addresses. But inside my VPN tunnel, I don't need to do that because it's under my administration. I can route my own private addresses between my own internal sites. And this is exactly what the exemption is used for. Now, typically the way you see this implemented is that an access list is used, so we can match not only where the traffic is coming from, but where the traffic is going to. So with this example, I would say on the ASA2, I want to match, so I'll say access list 1, permit IP from 10.0.125.0/24 to 172.16.34.0/24. So I have an access list matching traffic from VLAN 125 going to VLAN 34. Then I'm going to reference this from a NAT statement, but this is going to be the NAT 0. So NAT 0 is the NAT exemption. Now in outside of the IPsec design, what's going on specifically here, I need to exempt these packets that are coming from the VLAN 125. I need to exempt them when they're moving to the DMZ. So I'll create an access list that says, I don't really care what the source is, but I want to know, is the destination 10.0.0.0/24? If that is true, do not go through the NAT classifier. So we're not going to change your addresses. You can just route the traffic directly between them. And that's why I'm getting this error here that it says that we don't know how to do the translation, because the inside a NAT statement here, this says that the traffic should be translated. But there's no corresponding global that says, what are you actually going to translate it to? Now, to do this again, first thing I'm going to do is configure an access list. So we'll say access list NAT exemption is going to permit traffic that's coming from anywhere. I don't care where it came from. But as long as it's going to 10.0.0.0/24, that's really what I care about. So I know it's going towards the DMZ. Now I'll have a NAT statement for packets coming in the inside. They're going to be exempt from NAT, so NAT 0, if they match this access list NAT exemption. So now I should be able to see that from router 5, if I were to ping this address, that the traffic is not going to be translated between them. And if we looked at the ASA and looked at the show connections, we see there is a connection from router 5 that's going to the AAA server at port 80. But if we look at the show xlate, there's not a translation between them. So there is a translation from the outside in. This is our static PAT translation. But there is not a translation when we are going from inside to DMZ. So it can be kind of confusing here when you have more than 2 interfaces that are part of the NAT process. Because if I only have inside and outside, it's obvious where the traffic flows are going. It's coming from inside and it's going to outside, or it's coming from outside and going to inside. But anytime you have 3 or more, you essentially need to think about what are all the possible traffic flows. That I could go inside out, outside in, inside DMZ, DMZ in, outside DMZ, DMZ out. So from the NAT process perspective, there's 6 potential classifiers that I would need to deal with. And whether we're doing a dynamic versus a static translation is then going to control which links can you move between. Now I'm doing here a dynamic translation from inside to out. This implicitly then means I cannot move the traffic from outside to in, because it's required that the inside host first initiates the session before the dynamic entry can be used. However, for the outside to DMZ static translation, since this entry is always in the table, I can initiate the traffic from the outside in. Then for inside to the DMZ, I'm sending this through the exemption, which is the NAT 0. So it means the traffic will not be translated between those two interfaces. Now, if you take a look at the documentation, they do have examples of all of these variations. If you go to the ASA 8.0 configs, then under configuring the firewall, configuring NAT, it talks about the difference here between the static and dynamic NAT and PAT, bypassing NAT when NAT control is enabled, then the difference between the identity NAT versus the NAT exemption. And again, the difference is that with identity NAT, that is an inside-outside translation that does not allow you to initiate outside back in. But a NAT exemption would allow you to initiate the traffic from the outside in. Now, there's two other variations here that are called actually, here are the examples here, the identity NAT versus the NAT exemption, where the NAT exemption is using the access list, like I did in my case. The identity NAT would just be matching on what are the sources of the traffic. Now, the two additional ones are known as the dynamic policy NAT and the static policy NAT. Now, what these two are used for is to allow a translation conditionally depending on where the traffic is going to. So we can map the same inside address to multiple addresses or different addresses on the outside depending on how the traffic is classified. So for example, I could say that if I'm using web browsing, I'm going to hit one pool. If I'm using Telnet, I'm going to hit another pool. Now, this type of translation is useful when you have multiple links to multiple providers and you're trying to do essentially a policy routing of one application versus another. Where maybe one of my links, I want to use this for my voice traffic because it's guaranteed low latency, and the other one I'm going to use for any other traffic. I could force the voice traffic to be translated one way and then all of the other traffic to be translated the other way. But again, since this is a dynamic translation, the key is that we cannot go outside to in. We would have to wait until we initiate from the inside out, and then we could return back in. This is the difference between the static version and the dynamic version. Static policy NAT is still based on where the destination you're going to is, but it allows you to initiate from the outside back to the inside network. So let's say, for example, that now I want to do a couple additional translations that when traffic is coming from router 6's address here, I want it to be conditionally translated depending on what my actual traffic flow is. So let's say that if I'm going to router 1 or I'm going to router 2, I'm going to have my addresses translated to 200.0.122, let's say .101. So this will be our translation A. Then I want a second translation that'll go to a different address. We'll say 200.0.122.102 if I send my traffic to router 3. So it's the same inside host, but it's different outside destinations. So I could either do this based on the service, like is it Telnet, is it HTTP, or I could do it just based on the source and destination addresses. So to start here, I'm going to need to have two different access lists that are going to be used for the classifier. Okay, the first one is going to be for the traffic going to router 1 and to router 2. So let's say access list translation A is going to permit the traffic that's coming from router 6, so 56.6, and then it's going either to, let's use the loopback addresses, we'll say 200.0.0.1 or 2, then the second translation, or translation B, is going to be if I go to the address of router 3. So if we show run access list, 2 different classifiers I'm using. We have the A translation, and then we have the B translation. It's coming from the same inside host, but it depends on where I'm going to. Now, since this is a dynamic translation, it means that I need to specify the global pool. So once the classifier is matched, what am I actually going to change the addresses to? Now, if we look at the NAT process, I already have a rule number 1. So I'm going to need to use additional rules. I'll say these are rules 2 and 3. As long as they correlate to what I match in the global pool, that's really all that matters. So NAT rule 1 is matching to global 1. NAT rule 2 is going to match to global 2. So NAT on the inside for rule number 2 says I'm going to use access list that is translation A. NAT rule 3 says I'm using translation B. The global pool on the outside for translation 2 is 200.0.122.101. So it's a port address translation. It's a NAT overload. Then for the third rule, I'm translating to the 102 address. So now what we should see is that depending on where the traffic is going, so let's turn on logging on, and logging console 7. When router 6 sends traffic to 200.0.0.1, we should see that this is translated to the 101 address, which it is. Likewise, if the traffic is going to 2, likewise is translated to that same address. Because this, the access list used for the classifier, it's matching the same global pool. So they were both matched under NAT rule 2. Now, however, if I were going to router 3's address, we can see now the address is translated to the 102. So the classifier is using not only the source address, which we see here is the translation here. It says, built a dynamic TCP translation from the inside to the outside based on translation A. Then I built another translation from router 6 to router 3 based on translation B. Now, if I try to move from the outside back in, let's say I were to go to router 2 and telnet to 200.0.122.101. And let's see, I think I have this denied by the access list. Let's say show run access list. On access list, outside in, let's permit all telnet traffic. So from router 2, we can see that we still cannot initiate the traffic from the outside to inside. If I were to try that to the 102, likewise, that's not going to work. If we look at the show xlate in detail, we see that there's the translation based on rule B that says this host on the inside is being translated to this host on the outside based on whatever was matched in that particular access list. So again, with the dynamic translations, whether it's a dynamic 1-to-1 NAT, a dynamic 1-to, or a many-to-1 port translation, the NAT identity identity NAT or the dynamic policy NAT, the key is that these are inside to outside translations, not outside to inside. For the static versions, the static NAT, static PAT, the NAT exemption, and the static policy NAT, these allow your outside to inside translations. Now, this very last one, the static policy NAT, this one is kind of finicky. There's a couple of caveats that go along with this. And if you look at the documentation for using the policy NAT, if you look under the static section, it says that for policy static NAT, you can initiate traffic to and from the real host. So it's from inside out and outside in. However, the destination address used in the access list is only used for traffic initiated by the real host. For traffic that is to the real host from the destination network, the source address is not checked. And whatever is the first matching rule for the real host address is going to be used. So essentially what this means, in our case, if we look at this, the configuration of the rule, we show run access list and show run NAT. Translation rule A says that the translation is really only supposed to happen when we're going from 6 to 1 or from 6 to 2. But if I were to change this to a static translation, so a static policy NAT, then essentially it's not going to match the destination portion of the ACL. So it essentially turns into the same thing as just a normal static PAT translation or a normal static NAT translation. So I'm not really 100% sure what's the real application of this last one with the static policy NAT, because you would figure that you would want to try to do this bidirectionally, where you're going to do a static translation conditionally based on where the traffic is sourced from, but the classifier doesn't allow you to do that. And you'll see they talk about a couple reasons why you can't do that, where the real addresses on the inside cannot share the same mapped addresses, and it's a logic problem with the translation table, that you can go from inside out, but you cannot do the same translation from the outside back inside. Now you'll see the Volume 1 workbook does a lot of examples on this that you may want to try out, but the real important ones I would say about this are going to be the normal dynamic NAT translation, where we are going from the inside network, and then we're doing either a one-to-one translation or an overload translation, let's say to that interface. When we do the static port forwarding, so I want the ACS server on port 80 to be listening on a particular address, and the other one is the NAT exemption, because the NAT exemption needs to be used extensively when we get into VPNs. So we'll see, like when we do the site-to-site VPNs or when we do the remote access VPNs, that if I'm trying to encrypt traffic from here to here, I need to make sure that when the traffic is actually routed, it does not hit the NAT classifier first. Otherwise, when it gets to the other end of the tunnel, the IPsec rule or the proxy ACL on router 3 would deny this as it's coming in because it doesn't have the correct source address.